We're on lesson 3 of chapter 8, which is line and angle relationships. First, we're going to identify parallel, perpendicular, and skew lines. Then we're going to use angle relationships to find angle measures. So here are 3 vocab words to start out this lesson. The first one is perpendicular lines. Perpendicular lines are going in a direction so that they intersect and form 90-degree angles. So if you take these lines, for example, these are perpendicular because they form a 90-degree angle here, 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 and here. It's almost like a perfect crossing. And if you think about it, it kind of looks like 2 streets crossing perfectly. One of them is going north and south, the other one is going east and west. And they create that 90-degree angle in the process. Parallel lines are kind of like the opposite, actually. Parallel lines are lines in the same plane that will never intersect. So these 2 lines, for example, are both on this background here, so they're on the same plane, but these ones are never going to touch, and that's because they're going at the same exact angle. So these could go on forever in this direction, and they would never touch because they're not getting any closer or any farther away from each other. Same thing with this direction. So that's what parallel lines are. Skew lines are a little bit different. They don't intersect either, but that's not because they're traveling parallel. You see, this one's kind of traveling that way. This one's traveling this way. You think they would cross. They don't intersect, however, because they are on different planes. For example, if you think of a room, we have a floor and we have a ceiling. So if this line was on the floor too, it would be crossing right here. But since it's not, they're never going to cross either, only because they're on different planes. So that's what makes them skew, lines on different planes that don't cross. So using this figure, we can answer some of these questions. We have to tell whether the lines in the figure appear parallel, perpendicular, or skew. We have AB, so AB, this up and down line here. We have AC, this line right here. Well, I see that it crosses, and then it crosses what appears to be 90-degree angles on all 4 sides. If you remember what that means, that would be perpendicular. CE and BD are our next lines. So CE is over here. BD is over here. I'm noticing these lines are not crossing. Is it because they are parallel? No, it doesn't appear so. This one's going this way and this one's going sideways. These ones, however, are not crossing because they're on different planes. This one's on the ceiling. This one's attached to the floor. So we're going to call these skew. Line AC and line BD. Line AC is right here. Line BD is down here. You might be tempted to say these are on different planes, but actually if you look at this right here, this is a plane, this plane right in the front. So technically AC and BD are on the same plane. They're both on this wall here. And they're heading in the exact same direction, if you'll notice that. Heading in the exact same direction means they're not going to get any closer or farther away, which tells me that they are parallel. Moving on to part 2 of our lesson, where we can learn 3 more vocab words. The first one to learn is adjacent angles. Adjacent angles are angles that share a common vertex and a common side, which would be right here in this case, but no interior points that they share. And that makes sense. If there's a dot somewhere inside this 1, it's not going to be inside this 2. An interesting thing to note here is that adjacent angles formed by intersecting lines are supplementary. Even though I don't know their angle numbers, I notice that when you add them together, they make this straight line right here. So angle 1 plus angle 2 equal 180 degrees. So we'll be able to use that when we do our math in a little bit. Vertical angles then are opposite angles formed by 2 intersecting lines. So if you go to the opposite corner of 1, you'll find its vertical angle, angle 3. Opposite of 2 would be over here at 4. Something you'll notice that these look very similar to each other, and that's because it's true. Vertical angles have the same exact measure. So therefore, angle 2 equals angle 4, and angle 1 equals angle 3. The third word then is transversal. A transversal is a line that intersects 2 or more lines that lie on the same plane. Transversals to parallel lines, such as these for example, form special angle pairs. This is kind of going out of order, but the first one I will look at is corresponding angles. So this transversal, which is going at a straight line here, creates an angle with this one right here. Well, because these two lines are parallel, the top left and the top left one are actually going to match, as will the bottom left and the bottom left, top right, and bottom right and bottom right. And as I said before, that's because these are exactly parallel. They're going at the same direction as the other one, so it would make sense that their angles are also the same. So another thing you'll notice then is that alternate exterior angles are the same. Since these vertical angles would be the same, this angle is the same as that angle, which is the same as this angle. If you follow that, same thing with the one over here. This is the same as this, the vertical angle, which is the same as that one if we look at our corresponding angles. Alternate interior ones works exactly the same. This one is the same as that one, which is corresponding to this one. So knowing vertical angles, we could figure all of these angles out. So let's try this out. It says line N is parallel to line P. That's what this symbol means, that's parallel. It says find the measures of each angle. And it only tells us one angle. We have to figure out all other 7 angles in this transversal. Sounds challenging, but I think we can figure it out. For example, I know that this 55 degrees and this 5 are adjacent angles. Remember our last thing we talked about, adjacent angles are supplementary. So 55 and angle 5, 55 plus we'll say x because I don't want to say 5, equals 180 degrees. Subtract 55. So then x would equal 125 degrees. So we figured out angle 5. Now we can use some of the properties that we know. I know that this one and this one are vertical, so 6 is going to be the same as this angle, which is 55 degrees. I know that angle 5 and angle 7 are vertical, so angle 7 is going to be the same as angle 5, which is 125 degrees. Now I have these 4 angles down here. Well, remember it told me that these two lines are parallel. So these ones are going to correspond to their partners on the other parallel line. So this 55 is the bottom left, so that would be right here, this bottom left. So angle 1 is 55 degrees. Angle 4 is the top left of this one, which is angle 7 over here. Angle 7 is 125, so angle 4 is 125. Angle 3, which is the top right on this line here, is the same as 6, which is the top right there. 6 is 55, so that's what 3 is as well. Angle 2 then matches up with angle 5. They're both the bottom right. Angle 5 is 125. Angle 2 is 125. So only knowing one angle in this entire transversal problem, we can solve all other angles using all the properties we just learned.